Hello friends, welcome to Study by Technologies. In our session for electronics engineering, today we will discuss about operational amplifiers, or popularly known as op-amp. So we will discuss like what are the basics of op-amp first of all, and then we will discuss about how it can be designed to be used as a differentiator. Okay. So now first of all regarding op-amp. So I'm sure some of you might have seen a structure like in your books. Kind of a structure is something this way, like this. Let me make it in a little bit different color. Yeah. Okay. And we have something kind of this way and this way. Right. It seems a kind of a small triangle here, and it has its own couple of terminals, like this one. Then we have this one. After that, then we have this one, and here we have for supply voltage. Here as well. Alright, now let me see how it actually looks like. Here we have like kind of negative sign. Here we have a positive sign, right? This is V1 input voltage. This is input voltage V2. Okay. Then we have a supply voltage over here, like we supply. Okay. So here we have kind of we supply. Okay, positive V supply, and here we have negative V supply. Fine. And this terminal will be our output. This will show you the output part. Okay. Output. Like. Okay. Now here, let me mention it. It's a kind of V output. Fine. So then operational amplifier or op-amp is a voltage amplifying device to be used with the external feedback components such as resistors or capacitors between its output and input terminal. So it is a high gain electronic voltage amplifier with a differential input and usually a single ended output. So this is a basic layout of an op-amp. So now let me show you the detailed description of this and how it is actually present here and associated within the IC chip. So let me make it a little bit bigger diagram like this way. Okay. Then we have this V1 terminal, okay, which is associated to along with the input impedance connected to the V2. Fine. Here we have a ground terminal. Fine. Like this way. Okay. So this will be our internal impedance here. Okay, and this will be your minus section, and this will be your plus section. Fine. Then I'll explain this about minus and plus also. Then we have a kind of amplifier gain here, that is okay. Again, this is set to ground, and then here we have output impedance. Okay, you can represent it as Z out. Clear? And here we have V output, which can further be associated with the ground here. Fine. And then here also we have supply voltage, that is plus V supply and minus V supply. Fine. So this is how you can define a op-amp here. Here in this case, this negative sign over here, it shows inverting input. Okay, and this one is your non-inverting input. Positive sign is non-inverting input. Okay, inverting input and non-inverting input. I'll explain you about this how this inverting and how this non-inverting here once we proceed from to the differential part actually. Okay, now the next thing is like over here is about the op-amp operation. Okay, now this amplifier differential input is consist of this non-inverting input with the voltage V plus, or that is a V2 as present over here, and the inverting input with voltage V1, right? And this whole voltage setup over here, this is actually called as your V differential. Okay, this is a differential voltage, V differential. Fine. So ideally, an op-amp amplifies only the difference in the voltage between these two terminals. These are also called as differential input voltage. And the output voltage will be amplifier open loop gain and difference of V2 and V1. Let me write it so that you can have a better view. The output voltage can be termed as V out, and this will be equal to amplifiers open loop gain, amplifiers open loop gain, okay, and V2 minus V1. Fine. So just remember this point. This is a very important case. I mean, this is the main case over here, which we will be studying here. So output is associated to the open loop gain and difference of the voltages. Now, if we talk about the differential amplifier, what is the differential amplifier? Let me make a mark here. Like we have a okay. Now we know that this op-amp is a differential amplifier, but whenever it is used in the open loop configuration, as we have just seen, then the gain of this op-amp is quite high. That means the value of AOL will be very, very high actually, and because of this, the output will always get saturated. So in order to avoid this condition, we must use op-amp in a feedback circuit. Feedback circuit is what? Like we are feeding back the output back to the input here, right? So there are two configurations which are used in case of feedback amplifiers. So let me go ahead and update it. The first configuration here is inverting feedback op-amp. Inverting feedback op-amp. Okay. So now let me draw the structure for the same, how it is actually looks like. It is something like, let's say, minus, plus. Okay. So we are talking about the inverting, so it is very obvious that this plus should be grounded. That means the voltage which is supplied to this particular input should be 0, right? And we are going to supply a voltage to the negative terminal, which must be associated with a resistor here. And let's say this is our voltage source. Fine. So this is a voltage source. The point is connected to the ground here, and this is R1, through which my voltage source is connected to the inverting terminal. And here we have output. We out, right? And now, as per the feedback phenomena, what we have to do? We have to connect a resistance from output to the input part, and this is termed as your feedback resistance. Okay, this is your feedback resistance. So this is the main circuit of your inverting feedback operational amplifier, right? In a similar manner, we have non-inverting feedback op-amp. Let me draw the same circuit for this kind of environment. Non-inverting feedback op-amp. Right? Now let me draw the structure for the same. Let me draw the main circuit for the same over here. Like again, we have, okay, we have minus, plus. So as we have already seen that this is a non-inverting feedback op-amp, it is very obvious like we should connect this non-inverting terminal to the ground. Okay, this is your R1. Okay, and this non-inverting terminal should be connected to the voltage source, right? And this is my VIN, right? And then now this will be your output. Again, since we are working on a feedback kind of mechanism, it is very obvious. Again, we have to connect a part of output to the back to the input, and this is must be connected by feedback resistor. Fine. So as per this, either we are applying input voltage either at the inverting terminal or non-inverting input terminal. I want all of you to have a look at this. This is inverting feedback op-amp. So we have applied the input source at inverting terminal. This one is a non-inverting, so we have supplied the voltage to non-inverting terminal. Okay. Now let's talk about op-amp as a differential amplifier. Op-amp as differential amplifier. Again, now since it is the differential setup, so it's very obvious, like we are going to use a feedback mechanism here as well. It's like this, over here. Okay. Fine. Then we have this one. Let's say this is inverting input, so I'm using this V1. Then we have another input over here, that is V2. Okay. And since this is a feedback mechanism, so I have to connect the output to the part of input. Let's say this is connected to R2, this one is connected to R1, like that. Okay, and this is our output voltage. Fine. So this is a differential amplifier in true sense, and because here we can control the gain by controlling the values of resistors R1 and R2. Right? Just control the value of these two resistors and you will be able to control the gain over here. Now we have two different cases. Like first case is like we have an inverting configuration, and in second case we can have a non-inverting configuration. So let me first of all discuss with the inverting configuration. Sorry for the typo. Inverting configuration. Under this inverting configuration, that means the voltage should be applied as this V1, right? In this case, this V2 must be 0, right? And in the similar way, we have a non-inverting configuration. Non-inverting configuration. Here we have V1 equal to 0, right? Now let's see what happens in this case. Like in case of this non-inverting, that is when V2 is set to 0, in that case the output will be, just for an example we can consider it, let's say during this time the output is V01. Okay, at the non-inverting configuration, when the V2 is set to 0, the output can be considered as, we just assume it like this way, like we have V out, which is equal to V01. Okay, and this V01 is further equal to what? It is equal to minus of R2 divided by R1, right? And this will be V1, right? You can see here, since we are using the negative term here, so that is the reason like it's showing here the phase of inverting terminal, inverting configuration. Okay. In a similar manner, the thing is like if we are using a non-inverting, in this case, this V output will become, in this case, this V output, this becomes, one sec, V02. We assume it to be like V02 here, right? V02 or V02, whatever is convenient to you. And then in this case, the gain will be 1 plus R2 upon R1 then we have V2, right? So for inverting configuration, the output is minus R2 upon R1 into V1, and for the non-inverting configuration, the output will be 1 plus R2 upon R1, right? Now let's say we have kind of both V1 and V2 are acting simultaneously. So what does it mean? It simply means, like, let's say here, if both V1 and V2 are acting simultaneously, so we just have to make a sum of V01 and V02, right? It's like V output. In this case, V output will become equal to V01 plus V02. Now, what is V01 and V02? These are minus R2 upon R1 into V1 plus 1 plus R2 upon R1 into V2. R1 into V2. Fine. Now, since we need a kind of a uniform equation, and let's suppose we needed something like this way, where the output is equal to some constant multiplied by the difference of voltages V1, right? Here, this is my constant, right? This is a constant. None. In this case, we need to ensure that the gain that is applied to both the inputs should be equal. So suppose in this case, if the gain that is applied to both the input is R2 upon R1, then we can use this configuration as a differential amplifier. Because the thing is, like, for one, the gain is minus R2 upon R1, and for the other, the gain is 1 plus R2 upon R1. So my requirement is, like, if the gain for both of them is R2 upon R1, in that case, we can come out with this second equation over here, right? Then only we can use this amplifier as a differential amplifier. So, and finally, we can achieve our requirement as output to be the difference of two voltages and multiplied by some gain factor, as I have shown here in this equation actually. So now the requirement is to achieve equal gain, and for this, what we have to do, by anyhow, we have to make sure that 1 plus R2 upon R1 should be equal to minus R2 upon R1. We have to design our circuit in such a manner that 1 plus R2 upon R1 become equal to minus of R2 upon R1. Alright? So one can write it, change this equation to some place out. Let's say here, this LHS, if we talk about, so we can write this equation as R1 plus R2 upon R1. Right? This is the LHS part. Now, if we multiply this equation, this term as well, actually, if we try to multiply it by R2 upon R1 plus R2. Right? In that case, this R1 plus R2 will be cancelled and the output will be R2 upon R1, which is equal to this minus R2 upon R1 in terms of magnitude. Right? So this means that instead of applying the voltage source directly over this V2, we have to apply this voltage source through some voltage divider circuit. Let me go back to the previous diagram. Here, I was simply applying the voltage directly to this terminal. So instead of applying a voltage directly to this terminal, we have to apply the voltage through some voltage divider. Okay? Now, how can I design a voltage divider over here? Let's have a look at the figure that I'm going to draw now. We have this, this, this. Okay, like this way. Fine. This is R1. Fine. And this is the voltage V1. Alright. Then we have another source of voltage, that is V2. This is applied to this resistance. This is the plus terminal. This is the minus terminal. Okay. Then like this. Here also we have same level of resistances, R1 and R2. Fine. Then we can have output like this. And here we have R2. Right? So this is a configuration that we can use for the differential setup here. And this R1 and R2, which is associated with this V2, are the part of your voltage divider. Now let me figure out a point over here. What should be the voltage over here? Let's say voltage drop at this point, which is coming through the voltage divider circuit, is, let's say, this is V. Okay, so this V will be equal to what? As you can see here, that V will be, which is coming through some voltage divider circuit, it will be R2 upon R1 plus R2. 2 multiplied by V2. Right? Now for a moment, let's say V1 is 0. Let us assume that if V1 is equal to 0, then again it will be a non-inverting circuit, right? Non-inverting configuration. Then what will happen? Then in this case, V output will be equal to 1 plus R2 upon R1, 1 plus R2 upon R1, okay, multiplied by, let me drag it over here, multiplied by, here we have R2 upon R1 plus R2. multiplied by V2, right? Now if we write the entire equation in some different manner, this case that's V out. Here we are still considering that this V1 is set to 0, okay? Now if we write this equation in this form, here it will become R1 plus R2 upon R1, okay? And here it will become, it has actually not become R2 upon R1 plus R2, right? This will be V2. Now what will happen? This R1 plus R2 will be cancelled out on top and bottom, and this V output will become R2 upon R1 multiplied by V2. V output will become R2 upon R1 times V2, right? Now in this case again, let's say we supply a voltage to V1. V1 start. V1 start, okay? That means I'm going to supply the voltage on V1. Now what will happen? In this case, V output will be equal to R2 upon R1 V2 minus V1. And this is the equation for your differential or differentiator in case of op-amp setup. Alright, and this satisfies our requirement that the differences of voltage multiplied by some constant factor, which is nothing but R2 upon R1, will be provided as an output, and you can control the gain by controlling the values of this R2 and R1. So I hope you like the video, and if you have any doubts, any queries, please feel free to let us know, and please share and subscribe the channel so that we can reach to more number of students. Have a nice time ahead and take a very good care of yourself. Bye bye.